Hello and welcome to our lesson on a general strategy for factoring. So when we're factoring, we've talked about a whole bunch of different processes. We said the first thing that we should try to do is look for a GCF, and then we talked about grouping and bottoms up and differences of squares and sums and differences of cubes. And if you're working on one practice, let's say it's the factoring a difference of squares practice. In that practice, if that's all you're doing, you know exactly which process you're using every single time. Now, if I gave you, let's say, a quiz and there were a dozen different problems and it wasn't separated into squares or cubes or used bottoms up, if it was just, here's a bunch of mixed practice or mixed problems on your quiz, factor, what's the general approach? So in general, if you have a problem that says to factor and I don't tell you what type of factoring you're using, what should you do? That's what we're talking about today. Well, the first thing you want to do is, before you actually start factoring, the first thing you want to do is make sure that your terms are in order. And when I say in order, I mean in descending order. I guess let's put that here. Let's say they are in descending order. That is the proper format for a polynomial anyhow, and that's what we want to have established before we even start factoring. And technically, when our polynomial, the terms of our polynomial are in descending order, we say that that polynomial is in standard form. So the standard form for a polynomial is to put its terms in descending order. So for example, on number 1, 5x squared plus 2x plus 2, before we would attempt to factor that, the 2x squared should be first, the 5x should be in the middle, the positive 2 should be at the end. Okay? Similarly with number 2, the 3x cubed is where it should be, but the positive x squared should be next, the positive 2x should be third, and the constant of negative 4 should be at the end. So before we even start factoring, we want to make sure the terms are in order, in descending order in particular, and that is to put our polynomial in the proper standard form. Okay, now, once we start factoring, the first step, no matter what process we will apply afterward, secondly, what we want to try to do is, if it's possible, factor out a GCF. Okay, if it's possible to take out a GCF, we want to do that before we attempt anything else. Okay, so for number 3, 72x squared plus 2, those two have a 2 in common, and so that 2 that they have in common should be factored out as a GCF. So the GCF of 2 gets factored out, and that leaves us 36x squared plus 1. And that would be all that we could do with that problem. If you look at number 4, there's the same GCF of 2, and when the 2 comes out of this one, a 36x squared minus 1 is left, so this one we could continue. So this one would be done here, and then here we would continue to factor the difference of squares. And then if we look at the 5th example here, the 3rd one in this set, there is no GCF. So there is no GCF, which means we would try to then just factor the difference of squares, right? Same thing we have in the number 4. The difference of squares we would continue to factor. On number 5, we would just factor. So if it's possible, we take out a GCF. So if you look at number 3, we took out a GCF, and then we would be done. And sometimes that's it. Sometimes it's a GCF and you're done. And sometimes you take out a GCF and then you can continue to factor. And then sometimes there isn't a GCF. Sometimes you just go straight into your factoring process. Okay? So you've got all those options, but you want to be looking for a GCF before you attempt anything else. And then what else we attempt depends on the number of terms. So the process used to continue is based off the number of terms that are in our polynomial. So third, we're looking at how many terms are there. If there are 4 terms, we said we're going to factor by grouping. That's where we cut our 4 terms into 2 groups of 2 and look for the GCF in each group. We said if there are 3 terms, then we're going to factor using bottoms up. And then if there are 2 terms, then you're trying to identify whether the terms represent a difference of squares. And in that case, we'd factor into conjugate binomials. Or do we have a sum or difference of cubes, in which case we could apply our formula, or if you remember the patterns in the formula. Okay? So number 6, for instance, there's our 4 terms. Let's see if we can highlight here. If we have 4 terms, then we're going to use grouping to factor. So these terms, notice, are in order. There's no GCF, so we have 4 terms. Let's cut this into 2 groups. In the first group, we have in common an x squared, which would leave us an x minus 3 if we factored it out. Second group, if we factor out the positive 5 they have in common, then we're left with another x minus 3. So now we can factor out that common x minus 3, and that's going to leave us an x squared plus 5. And there it is, all factored by grouping. Okay. Then we said if we've got 3 terms, if there are 3 terms, that's what we have going on in number 7, that we're going to factor using bottoms up. So for bottoms up, we multiply our first and last number. 4 times negative 5 gives us a negative 20. And we want to find factors that make the middle number, which is a negative 1. So we can use a positive 4 and a negative 5 to both multiply to negative 20 and add to the negative 1 that's in the middle. So once we have those factors, we divide by our first number, which is 4. And then we reduce if we can. Now we can't reduce negative 5/4, but we can reduce 4 over 4 to 1 over 1. And then we're going to read these resulting reduced fractions from the bottom up to get our factors. So 1x plus 1 is going to be a factor. And then 4x minus 5 is going to be our other factor. All right, and then finally, if we have 2 terms, we're trying to identify whether we have a difference of squares or a sum or difference of cubes. So if we have squares, let me change this. If we have squares, that's what we have here in number 8, we want to rewrite our terms as squares and then factor into conjugate binomials. So on number 8, what are we squaring to get 49x squared, and what are we squaring to get 16? Well, the square root of 49 is 7, and if I divide this exponent by 2, I get x, and the square root of 16 is 4. So these are going to be the bases of my squares that go into my conjugate binomials. So this is going to factor into a 7x plus 4 and a 7x minus 4. Okay? Now if we have cubes, that's the last one here. Do I have another color? Oh yeah, orange. If we have cubes, that's what we have here, then we're going to rewrite our terms as cubes and factor using our formula or our patterns from our formula. So we want to know what are we cubing to get 8x cubed minus what are we cubing to get 27. Well, to get 8x cubed, the cube root of 8 is 2, and if we divide this exponent by 3, that means x to the first has to be here, and the cube root of 27 is 3. So these are the bases of my cubes that are going to go into my binomial, and then I'm going to use them in my trinomial. So remember the signs in our binomial. The sign in the binomial is the same, and then the trinomial we've got the opposite sign, and then the last one's always positive. The bases of the cubes go into the binomial, so the 2x and the minus 3. And then first term of the trinomial is the result of squaring the first term of the binomial, so 2x squared. 2x times 2x is going to give us a 4x squared here. And then in the middle, I got to multiply my a and my b, my first term and my second term, so 2x times 3 is going to give me a 6x. And then at the end here of my trinomial, I'm going to multiply my second term. Square my second term. So 3 times 3 makes a 9 go here. And just so you have everything in one place, let me go ahead and give you the formula too. So if we wanted to use the formula, do this again, then you can, whatever you prefer, right? The formula says that if we have a, in this case being 2x, and b as 3, that a cubed minus, change colors. Formula says if we have a cubed minus b cubed, it's going to factor into a minus b, and then a squared plus ab plus b squared. So rewriting them as cubes, we identified a as 2x, so 2x would go here, b was 3, so 3 would go here, and then a gets squared, so 2x gets squared, and then a times b means 2x gets multiplied by 3, and then b squared means 3 gets squared. So this factors into 2x minus 3, and then 2x squared would be a 4x squared here, right? 2 gets squared, x gets squared, plus 2x times 3 is 6x, plus b squared is going to be 9. So whether you're good with the patterns or you need to see it in the formula, you've got either option. Okay? So that's the gist of it, unless nothing at all works. So lastly, oops, I wanted the highlighter. Lastly, so let's call this number 4, okay? If nothing works, if no factoring is possible, that means the polynomial is prime, and this really should be the last resort, okay? So sometimes it's obvious that your polynomial is prime. For example here, these terms are in order, there's no GCF, and I've got 3 terms, so I'm going to try to use bottoms up, but the only factors of 17 are 1 and 17, or if you wanted to stretch, -1, -17, but neither one of those combinations is going to give us a positive 3 in the middle. There are no factors of 17 that make 3, so there's no way to factor this thing. It is prime. Okay? Number 11 is not as obvious, so be careful. Again, terms are in order, no GCF. If I try to use bottoms up here with these 3 terms, I'm looking for factors of 9, which would be, let's see, 1 and 9, or -1 and -9, or 3 and 3, or -3 and -3. Those are the only ways to get a positive 9. And you might be tempted to say that 1 and 9 will work if the 1 is negative, because this combination does add to the positive 8 that's in the middle. The problem is this combination does not multiply to a positive 9, which is what we need. So be careful here, because it's tempting. But if we're looking for a positive 9, these are the options, and none of those options add to 8, right? This option makes 10, this makes -10, this makes 6, this makes -6. None of them get me the positive 8 here. So this, again, has no factors. So this, again, is prime. Not as obvious, again, so be careful, but it's still prime. And then the last one, again, is tricky because it looks like something we can factor. We know that 4x squared produces 16x squared, and we know that 5 squared produces 25. But this is a problem. Remember, if we try to make this 4x plus 5 and 4x minus 5, okay, that we do in fact get a 16x squared, but we get a negative 20x and a positive 20x, and those canceled. That's good, right? But what happens at the end here when we multiply a positive 5 and a negative 5 is we get a negative 25. The only way these middle terms cancel is if one's got a plus, one's got a minus, which means this last product has to be negative. So there's no way to get the middles to cancel and for that to be positive. So when we have a sum of squares, we will not be able to factor. A sum of squares is always prime. This is a sum of squares. Okay? This is always prime. Okay? So just a little recap. We said put the terms in order. First thing we want to do, that's really before we factor, put the terms in order. And then, if it's possible, we're going to look for a GCF, factor it out. If it's there, if it's not, we'll try to continue. If it is and we can't continue, then we could be done. The GCF, if possible, and it's possible, again, that you're done at this step. And then we factor based off the number of terms. Okay, factor based on number of terms. We said for 4 terms, we're grouping. We said for 3 terms, we're going to try to use bottoms up. And then we said for 2 terms, we're looking for a difference of squares, or we're looking for a sum or difference of cubes. Okay? And again, if none of that applies, so if we can't take out a GCF, if we can't factor by grouping, if there are no factors that are possible for bottoms up, if our 2 terms, again, don't have a GCF and they aren't squares, they aren't cubes, a difference of squares or sum or difference of cubes, if none of this works, then our polynomial is prime. If no factoring works, if nothing works, it's prime. Okay, so there's our little recap. This would be one good place for you to reference basically 90% of what we've done in the module, although we have 2 topics remaining. They're connected though. We're going to be going from factoring expressions to using the factoring to solve equations. Something to look forward to. In the meantime, work on your practice, and if you're struggling, reach out. I'm here to help. All right, guys, take care.